So hi, in today's lecture we are going to find the first index of the targeted element. Okay, so they are giving us an array in a sorted order. Okay, and we have to find the index of the first element, and we have to find the first index of that element. So if the target value is 9, then we have to return 7 as an answer, because the first element, sorry, the first index of that element is present at index 7. Okay, if they have given if the target value is 5, then we have to return 3 as an answer. Okay, so I believe you got it. Now the first and the foremost approach, that we can just apply the linear search. Okay, so we can just simply apply a linear search in which we want to just find an element. Since we are starting it from the 0th index, okay, obviously we will be getting that the first occurrence of that element. Okay, so we can just simply return that index. Okay, so the for loop will look like this. For I will be coming from 0 and it will be going till n if a of I is equals to target. Okay, simply return I, that's it. But it might happen that the targeted value is not present inside an array. Okay, so we have to return -1 in that case. So what you can do over here, instead of returning, let's simply write answer as -1. Okay, and then I'll simply write over here answer is equals to I and break from the loop. That's it. And at last over here return answer. That's it. Okay, now talking about the space complexity and the time complexity, here over here, since we are just running a single for loop, so the time complexity will be order of n, and we are not taking any extra space, so the space complexity will be order of 1. Okay, now we can optimize this for finding the answer. Here we can see that the array is in a sorted order. Okay, so we have to think that can we apply a binary search in it. See, now the thing is that since we want to find the first occurrence, the index of the first occurrence of the targeted value, the thing is that, okay, we can apply the binary search. Okay, let's say this is a whole array. Okay, and after finding the mid, we are going to reside over here. Okay, now we have to think whether this 5 can be the first occurrence of the element 5 or not. It might be or it might not. Okay, so we have to store that the index of this particular element. Okay, and we have to search for the left hand side. Why left hand side? Because we want to find the first occurrence. Okay, but it might happen that, say, let's say if we did if the targeted value is 9. Okay, and while finding the mid, okay, we got over here. Okay, we are standing over here, so we can just simply search that whether the element is greater or smaller. If the targeted element is smaller, okay, we can simply search over here. If the element is greater, we can simply search over here. Okay, so there are some multiple if cases. So talking about approach 2. Now low, high and mid. Low will be 0, high will be 11. So 0 plus 11 whole divided by 2 will be 5. Now at index 5, 5 is present. Okay, now we have to think that whether this element can be the first occurrence of that targeted value or not. Okay, now let's say the targeted value over here is 5 only. Okay, since the element that mid is holding, okay, and the element that target is holding are same, so we can just store that value. Okay, store that value, in a sense store that index. So answer which was initially, let's say, -1. Now it is 5. Okay, 5 is nothing but the index, okay, not the value. Now after storing, we have to go on the left hand side. So since we have to go on the left hand side, so here in this case, high will be mid -1. Okay, now low will be as it is, high will be 4. 0 plus 4 whole divided by 2 will be 2. Now a of 2 is nothing but 3. Now here we can see that a of 2, which is mid, is not equals to target value. Okay, and here we can say that the target value is greater than mid, right? So we have to go on the right hand side. So here in this case, low will be, sorry, mid plus 1. Okay, so low will be 3, high will be 4. 3 plus 4 whole divided by 2 will be 3. Check, a of 3 is nothing but 5, right? Now target value and the mid value are same. Here also, here we can see that we got the answer, okay, but the computer doesn't. So again we have to move again we have to go on the left hand side, okay, because there might be a case that this element is not the first occurrence. So go on the left hand side, that means high is equals to mid -1. Okay, but before that we have to store that element because the mid value is equals to target value. So the answer will be 3 now. Now high will be mid -1, that will be 2. Sorry, high will be mid -1, that will be 2. This will be 3. Now since this is not the case, okay, low should be never be greater than high, so we have to terminate. Okay, so after that we have to simply return the answer, which is 3. Okay, and here we can see that the 3 is the right answer. So how can we code this? While low is less than high, less than equals to high, initially we have to find the mid value. So mid is equals to low plus high whole divided by 2. After that we have to check if a of mid is equals to target. If it is, then we have to store this. So answer is equals to mid, and initially answer will be -1, because it might happen that the element is not present inside an array, and we have to go on the left hand side. Okay, so high will be mid -1. This will be the first case. Okay, now after that, if a of mid is lesser than target, if a of mid is lesser than target, that means the target is greater, so we have to go on the right hand side. So low will be mid plus 1, and else that means target is lesser. Okay, so we have to go on the right hand side. So high will be mid -1. That's it. After that simply return answer. Okay, so I hope you got this. Now talking about the time and space complexity of this approach, since we can see that here we have applied binary search, okay, every time the data set is dividing by 2, so time complexity will be order of log n, and the space complexity, since this is an iterative approach, the space complexity is 1. Okay, so that's it. So I believe you got this approach, and that's it from my side. I'll see you in the next lecture. Till then, keep practicing. Thank you.